Hello, and welcome to this session on using Ansible with Checkpoint APIs. I'm your host, Dwayne, and I appreciate you having me here today. In this episode, we'll start separating the playbook logic from the playbook data. The first step is to move our variables to an external data file and include that in the playbooks. We'll continue to make our playbooks adaptive and flexible by providing default values for variables that go missing. This will be your first look at the wide world of Ansible filters. As always, we'll apply this methodology when working with checkpoint objects. So grab yourself a snack, a beverage, and let's get started. Writing variables directly into the main playbook results in a strong coupling of your playbook logic, the tasks, and the data for those tasks, the variables. This means you have to change your playbooks whenever you change the content of your variables. Ideally, a playbook should be designed to be as flexible as possible, but within reasonable limits. After all, this is automation and orchestration, not a full-size programming language and application development environment. Back in episode 5, I discussed the anatomy of playbooks. I highlighted the differences between play-specific variables and task-specific variables. Now we're going to get more surgical with our variables and move the task-specific variables to an external variables file. Most playbooks will be of a template variety when making everyday changes. If you have a template style playbook that is expecting a list of host objects, but for some reason that list isn't defined, the playbook will fail with an error. Here's an example of that. You can see that the list variable for the loop is undefined. Of course, you can manually disable that task by commenting it out, but now you're back to that strong coupling of logic and data. You could go litter your playbook with Ansible's equivalent of if-then statements to test for the existence of the variable. You could instead use tags on each task, but again, you're back to coupling, and tags tend to lead you into tag purgatory. Let's avoid these gimmicks altogether. Ansible provides you with a way to handle this inevitable situation. The answer lies in what Ansible calls a filter. Ansible has lots of filters to manipulate your data. The Jinja templating language adds even more. The Ansible filters and the Jinja filters work like functions in any other programming language. That's because these filters really are Python functions within Ansible. We'll start small and work with a filter named default. The default filter is used to return a given value when the input data source is undefined. This is not the same as a true-false test, however. Be careful not to confound these two. The filter functions are accessible via Jinja templating syntax. This means we use the syntax of double quote, quoted string of opening and closing curly braces. You pass your content, such as a variable, as the input to the filter function. This is done with the pipe character. The function receives input from the pipe, parses that input, and the return data is emitted in place. For the default filter, the alternate output is specified as a parameter of the function inside the parentheses. This emitted output becomes the dereferenced content in the Jinja templating marker space. When using the default filter, you have to consider what default value you want to return. You can return anything you want, so long as it's a valid YAML data type. Most importantly, you need to know where you are using the default filter, and you can only return a value that is suitable for that usage. Loop operators require a list as its input. We want to return a default value if our list variable is undefined. In the case of a loop, we have to return a list from the default filter. What do you want that default list to be, and with what content? Well, in this particular case, if our list variable is undefined, we don't really want to do anything. Very simple, we return an empty list. And this is what an empty list looks like in YAML. Just the open and close square braces. Putting it together, here's what it looks like. The variable containing a list of host objects is the input to the pipe, and if that variable is undefined, the default filter will return an empty list. If the loop operator receives an empty list, then it will cause the task to be skipped. This is a more elegant form of an if-then statement. Here's the complete task using a debug module in a loop. Here's what it looks like when ran in a playbook. Here's your first look at a task with status other than OK or changed. The play recap shows the number of tasks that were skipped, no tasks were OK, and of course no tasks were changed. With this new technique, you can start building your playbooks with some intelligence. Missing data is no longer a problem, and we can prevent failure of the playbooks. Very nice. Now we'll put that filter into action and see various use cases in live playbooks. In this section, you'll get a look at a bonus filter that makes the default filter even more powerful. Let's go check it out. Let's build a checkpoint host object. There's an old adage I learned from a web designer friend of mine: content dictates layout. The same thing applies here. You can't just go around building playbook tasks without really understanding your data source input. You know a host is a dictionary object with key value pairs. In the previous episodes, we already asked ourselves, what does a host object require? Name and IP address. Great. What else do we want? A comments line? Object color? What names do you want to give to the dictionary keys? I strongly recommend you do this with some wisdom and forethought. You might have to execute your playbook at 3 a.m., and that is not the time to troubleshoot. Our host object is going to follow the pattern of the Ansible module's key names, and here it is. The descriptions to the right of the keys are the object types for those keys. Most of these keys are just string types: name, color, comments, and so forth. Some of these are a list type. For these, you see the description is list/elements equals string. You'll see this in Ansible module documentation as well. This means the key itself is a list, but the items of the list are string type. One of the keys is nat settings. This key is a dictionary type with additional keys and values. The values of those inner keys are shown along with their value type. This is your host object model. Each of the object types have their own models. We'll see models of other objects soon. What if we only need or want one object for some one-off case? Should we make an allowance for one object versus a list of objects? No. As much as reasonably possible, do not make snowflakes. One object is just a list of one. We already had a list of none, so why deviate? That's how you create bugs. Whenever and as often as possible, always define your variables as a list of objects, even if it's only one. Make a pattern, make a habit, and above all else, be consistent. In the sample list on the right, host_objects is the name of the variable for this list. This is the variable we will use in the playbooks going forward. Create a new directory for your playbook and variables file. As for the name of the external variables file, I generally defer to using a simple vars.yml. There are times when you'll need more than this, and we'll see examples of these later in the series. In this directory, open your favorite text editor and create a new YAML file named vars.yml. Be sure you have the YAML opening and closing markers. In the vars.yml file, you'll start your content on the far left margin, not indented like it was in the main playbook. This file just contains static variable content, no operational logic. If you're thinking ahead and wondering, ooh, can I also use Jinja templating in vars.yml? The answer is yes. However, you probably don't want to do too much of that. Yes, there are valid cases, and we will see some of these. Jinja templating in general is part of the logic, just like the playbook tasks. You don't want to have logic in your data source. Go ahead and list whatever host objects you'd like to create. Be sure you follow the object model, however. No deviations. Next, create a new playbook file. We'll have our usual header section of name, host, connection, and turn off the facts gathering. Here's our section for variables. Add the lines for Ansible Network OS and API key. We still have the API key string in here. I know. Yes, this is moving soon. I don't want to throw you to the wolves just yet. You may be surprised to hear this, but no, this should not be in your external variables file. It has a home, just not this home. We are skipping that vars.yml file here on purpose, just so you can see the default filter in action first. Here's the task section where the repetitive actions live. This is the same task from episode 6, but with the host object list moved to the external variables file. Change the loop list to include a pipe to the default filter with a return value of the empty list. I added a call to the discard module at the end. This will be the model for our playbooks going forward. There's that word model again. Save this playbook and run it to verify the new structure. The host module task was skipped, just as expected. Now go back to your playbook and let's import that external variables file. Add a vars_files variable and we'll make it a YAML list. It will be a list of external file names in the current local directory. Add a list item for vars.yml. No further changes. Save it and run it. Since the host object's list variable is now defined, the playbook added those hosts with those properties. Excellent. This is the same as at the end of episode 6, except now you can edit vars.yml all you want and the main playbook never changes. This could even be frozen in a Git repo of some kind that you clone and reuse, but we won't do that here. Back in the main playbook, we need some updates to our task. In the playbook task, we only use the name and IP address fields. What about the comments and color? We didn't tell the task anything about these parameters, and the object module isn't a fortune teller, so the API server used server-side defaults just like Smart Console would. In the task for that object module, add the other module parameters from our host object variable. Let's also add a task in debug for the object facts like we did earlier to see our handiwork. Run the playbook and check it out. Here's our new host and the color. Very nice. While we're here, we need to cover one more thing. Using the default filter is a great and powerful tool to have in your toolkit. However, it can be overused and used improperly, which turns the tool into a weapon and used against you. How can the default filter go wrong? Well, let's find out. Each of the module parameters can also have default values returned if they aren't supplied by the input. As always, the default value must be appropriate for the place it is used. Let's use the comments parameter for example. The comments parameter is a string, and it can be blank or null, which is the server-side default. You could set the default value to be a null string, or you can make it a static string of your own. Within Jinja, to return a static string, you must use single quotes. The entire Jinja string is double quoted, remember? So internal strings must use single quotes. Another example is the object color parameter. The object color cannot be null, nor can it be blank. The server-side default is black, but you can make it any default you want. In this example, I will set the comments to a specific string, and for color, I will use gold, just for fun. I also made the label line a bit more presentable. For those of you who noticed, yes, I'm using dot notation for the variable keys instead of bracket notation, since I know these are safe to use here. In the external variables file, let's remove some fields from the host dictionaries so you can see the default filter in action when parsing the host properties. I'm keeping the same object name, but I'm removing the object color and comments from some of the items. So let's say the last playbook just ran, which it did. This next playbook does what we did before. Get a list of host objects on the server, one by one, and store the results in new host facts variable. Display the result of each host object. Here I'm combining everything we know so far into one task using the debug module. The hosts are in the register facts variable in a key named results, that is a list. This list is used in a loop. Each item in this list is a full host object with an Ansible facts key, which in turn has a key named for the checkpoint host object module. I'm using a custom variable and custom label. I'm using Jinja statements in the debug message to show only a few parts of interest, name, color, and comments. I'm using the same host object module task as the last playbook, except I'm changing the default value content for the object properties. I'm still using the same named list in a loop. Each host in the list variable doesn't have all of these values defined, so the default filter will kick in on those host properties. Here's the same host facts and debug to see the results. See what happened? Since the last playbook ran, a host object with that name already existed on the server with existing values for those properties. However, not all of those property values were in my variables file dictionary, yet they were defined in the task with a default value. Now we have to ask ourselves and answer several questions. Is this what we wanted? Would you always want to override server-side properties of existing objects like that? Do you expect you'll have to define some default for all possible parameters and properties of the objects? What if you only need to change a single property of an object, like a host IP or group membership? Do you need to redefine the entire set of object properties in your task or variable list? Doesn't this sound incredibly complicated and nearly impossible? Yeah, all of that is just dumb. No other way to say it. There is a better way. So how can you write a template-style playbook that allows you the flexibility to provide as many values as you wish, but only when you really want to provide them? For every other time, just ignore the missing properties. Welcome to the magic variable named omit. Omit is indeed magical and can sometimes be difficult to understand, but I promise you, I'll make it super easy right here, right now. Here's how it's used. Combine default with omit. Notice carefully that omit is not quoted. It is an internal Ansible magic variable and is only accessible within a Jinja statement. Omit does not return a null value like you might think. Instead, omit is like an eraser. It is a special value that feeds back to the module parameter and removes that entire parameter when the module is invoked. Here's a short test playbook with the debug module showing omit in action. Okay, first off, doesn't this look weird? How do I have these two lines like this? Why do they look like variables, but they're indented under the message parameter? This is an extra feature of the debug message parameter. While it doesn't look obvious at first, I'm actually specifying a dictionary for the message to display. These two lines are the keys of my inline dictionary. This dictionary has no assigned variable name, so what is it called? Yes, an anonymous dictionary. The variable foo in the Jinja statement is not defined, so the first line will default to the static string bar. What will happen to the second line since foo was not defined, but the default value is omit? Let's find out. Whoa, where's line 2? It was omitted. The whole parameter was erased. Nice trick, Ansible. You can use this in your module parameters too. For any module parameter that you want to be entirely optional, use omit as the default value. Here's a new version of the task using default omit. Here's a review of the host dictionary list with some values missing. Now the object module task won't fail for the missing values, and it won't use some default value that changes the existing objects. As I said in earlier episodes, just like Smart Console. Feel free to explore a bit on your own. See what you can create using these concepts and tools. You have lists with default empty lists for loops, default values for module parameters, omit for optional parameters, and Jinja to help tidy your output and access variable content. That's all for today. As always, be sure to commit this to your Git repo before you leave. Okay, now your playbooks can have logic, external data files, flexible tasks, and flexible module parameters. Your toolkit is expanding nicely. Well done. Be sure to hit that subscribe button below so you'll know when new content is available. Please leave a comment to let me and others know how this video helped you. Join me in the next video, and we'll be hitting the boosters on this project as we expand our playbooks with externally defined tasks and work with more checkpoint object types.